Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed with the topic of basic principle of metallurgy, concentration of the ores. There are different principles of metallurgy. We had started with how actually the process of metallurgy works, and in that the first step was concentration of ores. Today we are going to study about the next principle, that is extraction, and in that we are going to study about extraction of one of the metals, that is aluminium, and then we will get ourselves introduced with the topic of corrosion of metals. So without wasting time, let us start with our basic principles of metallurgy. The first basic principle, as I have informed you last time, pure metal is obtained from the ore by different stages, and in it the first stage is concentration of ores. What do you mean by concentration? Here the process of separating gangue, that is impurities, from the ores is called concentration of the ores. And what actually happens in this process is the concentration of the compound of the desired metal is increased. There are different ways which serve this purpose, and there are different general methods for the concentration of the ores. Under that, we had seen the different techniques. We have studied the techniques last time. Separation, which is based on gravitation. Under that, we had studied about Wilflet table and hydraulic separation method. Then we had seen the magnetic separation method, froth flotation method, and method of leaching. Now, we move towards the next step of metallurgy, that is now concentration of the ores. This step is over. After concentration, the next step of metallurgy is extraction of metals. As I have told you, we have studied about the reactivity series of metals in this chapter. Metals, all the metals are not very reactive. Some are very reactive, some are moderately reactive, and some are less reactive. And for each type of metals, different extraction techniques have to be utilized. So first what we will do, we will see the extraction of different types of metals. We will see the extraction of reactive metals, moderately reactive and less reactive. Then we will move towards the refining, and towards the end we will start with extraction of aluminium. Even though extraction of aluminium is given in between in this chapter, first we will see the different extractions. So first is the extraction of reactive metals. Now which are the reactive metals? Metals at the top of the reactivity series, they are considered to be highly reactive, and their reactivity decreases down the series. Different examples are there: potassium, sodium, aluminium. They are categorized as reactive metals. Now reactive metals, they have large capacity to form cations. Why? By losing of electrons which are present in their outermost shell. You have studied about sodium and formation of sodium chloride last year. Now these reactive metals, they react vigorously with dilute acids to give or liberate hydrogen gas, and highly reactive metals burn by reacting with oxygen from the air at room temperature, and hence their extraction has to be done by electrolytic reduction. About electrolysis, you have studied last year in section A in chapter number 5, that is acids, bases and salts. Now for the different metals, that is for sodium, calcium and magnesium, they are obtained by the electrolysis of their molten chloride salts. What happens in this process? Metal is deposited on the cathode while chlorine gas is liberated at the anode, and the electrode reactions during the electrolysis of molten sodium chloride to get sodium in the metallic form. Both the reactions I am expressing here One is the cathode reaction and the other is the anode reaction. Cathode reaction, Na plus electron forms Na, that is reduction. 2Cl minus forms Cl2 plus 2 electrons, that is oxidation. In this way, the extraction of reactive metals is carried out. Now let us see which techniques are applied in the case of moderately reactive metals. Now here you have to be careful. This paragraph can be given in the exam and then different questions can be asked on it, or they will ask you to write about the extraction of different types of metals. So the next is extraction of moderately. Moderately means medium. Now the metals in the middle of the reactivity series, for example iron, lead, copper, they are called as moderately reactive metals and they occur in the form of their sulfide salts or carbonate forms. Now, if you want to obtain the metals, in this case, it is very easier to obtain the metals from their oxides rather than sulfides or carbonates. How do these moderately reactive elements occur? They occur in the form of sulfide salts or carbonate, but if you want to extract the metals, then it becomes easier to extract them from their oxides, and so the sulfide ores or the carbonate ores have to be converted into oxides. Now how to convert them, we will see one by one. First, the sulfide ores, they are strongly heated in air to transform them into oxides, and this process is called as roasting. Here one definition is ready. Define roasting. Now such definition if it is asked, then you have to support the definition with the help of chemical equation for roasting. Carbonate ores. This is about sulfide ores. Now if carbonate ores you wish to transform them into oxides, then you have to strongly heat them in a limited supply of air to transform them into oxides, and this process is called as calcination. Now both the equations we will see, they have taken for zinc sulfide and zinc carbonate. So the example they have taken of moderately reactive metal, that is zinc, which is available in the form of sulfides and carbonates. So roasting 2ZnS in the presence of oxygen, because strongly heated in air means oxygen is there in the air. You get zinc oxide. So you want the zinc oxide plus sulfur dioxide gas is given out. Carbonate ores, if you are strongly heating in limited supply of air, it will get decomposed into zinc oxide with the liberation of carbon dioxide gas. So here you are transforming the sulfide ores and the carbonate ores into their oxide forms. Now the zinc oxide which you are getting here, it is then reduced to zinc by using the suitable reductant. Now apart from carbon, reactive metals such as you can see here, zinc oxide plus carbon gives zinc plus carbon monoxide. Now apart from carbon, reactive metals such as sodium, aluminium, they are also used as reducing agent for the reduction of metal oxide to obtain that particular metal. Look at the steps. Moderately reactive metals, they are available in the form of sulfide or carbonate ores. Their sulfide or carbonate ores are converted into their oxides. Now the reduction of that oxide into to get the pure metal, where not only carbon but certain reactive metals like aluminium, sodium are also used as reducing agents. Why? Because these metals, they displace a moderately reactive metal from its compound displacement reaction. Here one example you can see, manganese dioxide. When treated with aluminium, aluminium acts as the reducing agent. So you get manganese as the metal with the formation of aluminium oxide and liberation of heat. Now the heat which is evolved in the above reaction, it is so large that the metal is formed in the molten state. And another similar example here is of the thermit reaction. Ferric oxide treated with aluminium forms iron plus aluminium oxide plus heat. Now in your textbook page number 105, thermit welding, that diagram, that part they have removed out from the syllabus, but thermite reaction is there. Many a times students ask the question, teacher, thermite welding is removed. So what about the thermite reaction? Yes, it is not removed out from the syllabus. So you have to prepare the thermite reaction. Up till now, we have seen the extraction of highly reactive and moderately reactive metal. Now, let us move towards the less reactive ones. How are the less reactive metals extracted? Now, which are the less reactive metals? Metals which lie at the bottom of the reactivity series are less reactive. See, highly reactive at the top, moderately reactive in the middle, and less reactive towards the bottom. Now, which are the examples of less reactive metals? Gold, silver, platinum. These metals, they are found in the free state in nature, and hence their extraction is not very difficult. The reserves of copper in the free state, they are very few. So presently copper is found mainly in the form of copper sulfide. Now how is copper obtained? We have taken an example of less reactive metal, that is copper. It is obtained from copper sulfide by just heating in air. So 2Cu2S, heating in air means combines with oxygen forming Cu2O, that is its oxide, plus liberation of sulfur dioxide gas. Now this copper oxide or cupric oxide, when treated again with Cu2S, you will get copper with the liberation of sulfur dioxide. Now if you look in this chapter, n number of equations are there. Each and every equation, try to balance it on your own, because if you try to learn these equations, then towards the end you will only get confused. Now the two stages of metallurgy are over. One is concentration of the ores and the other is extraction. We have seen the extraction in the case of different types of metals. Now the last stage of metallurgy is refining of metals. Now you have obtained the metals from the ore. You have extracted it properly. Now you have to get the metal in the pure form. So here refining is the step. Metals which are obtained by the various reduction processes, they are not very pure, and somewhere they contain some amount of impurities, and these impurities need to be separated to obtain the pure metal. And which method here is used? The method used is electrolysis to obtain pure metals from the impure ones. I hope all the three stages of metallurgy are followed by you thoroughly. Concentration, extraction and refining, and in concentration different ways are there. Each and every way you should know it. Now let us move towards the extraction of one of the metals which is a part of our syllabus. Extraction of a highly reactive metal, that is aluminium. Let us move towards it. Extraction of aluminium. Now, as I have told you, aluminium is a highly reactive metal. It falls in the category of highly reactive metals along with sodium, or you can say potassium, and it does not occur in nature in the free state. Which are the ones which are found in the free state? The less reactive ones like gold, copper, platinum, etc. Now, this aluminium is not found in the free state. It is the third highly abundant material in the Earth's crust after oxygen and silicon. So how to extract this aluminium from its ore? The main ore of aluminium is the ore bauxite. So aluminium is extracted from its ore bauxite, having chemical formula Al2O3, n number of water molecules. Bauxite contains 30% to 70% of aluminium oxide, and the remaining part is impurities, that is gangue. It is made up of sand, silica, iron oxide, etc. And hence the different steps in the extraction of aluminium we are going to see one by one. You have studied about leaching in the topic of concentration of the ores. What I had told you in leaching, the first step in the extraction of metals, aluminium, gold and silver from their ores, is the method of leaching. What is done in the method of leaching? The ore is soaked in a certain solution for a long amount of time. So that technique you are going to use here in the extraction of aluminium. Now we move to the first step, that is concentration of the bauxite ore. This is our first step. As I have told you, bauxite is the main ore of aluminium. Here silica, ferric oxide and titanium oxide, that is TiO2, they are the impurities which are present in the bauxite, that is gangue, and separation of this impurities is done by leaching process. Here two methods you are going to study. One is the Byers method or the Hall's method. Now in the textbook, in your syllabus, they have given both the methods, so you have to prepare both. If they ask in the exam, give the extraction of aluminium using Byers method, then you will write the first one. If they tell Hall's method, then you are going to attempt the second one. Let us see how both these methods work and how we get aluminium. Now in both these methods, finally the concentrated alumina is obtained by calcination. Just now you have studied what is calcination. Carbonate ores are strongly heated in a limited supply of air to transform them into oxides, which is called calcination. So here you are going to use the same technique, that is calcination. What is the basic funda of Byers method? In the Byers process, the ore, that is the bauxite, is first ground in a ball mill. Then it is leached, means undergoes the process of leaching by heating with concentrated solution of caustic soda, that is NaOH, at a temperature of about 140 to 150 degrees Celsius under high pressure for about 2 to 8 hours in a digester. Here what happens? What does bauxite contain? Aluminium oxide. So aluminium oxide, it is amphoteric in nature, so it will react with the aqueous solution of sodium hydroxide, which is caustic soda, to form water soluble sodium aluminate. And what does this mean? Bauxite is leached by NaOH. Let us see the equation. Here we get the first equation. Aluminium oxide, that is bauxite, when treated with caustic soda, that is NaOH, it will form a precipitate of water soluble sodium aluminate, NaAlO2, with the liberation of water. See, n number of reactions you have to study over here, so be careful. So the first step in the Byers process is that you are treating the bauxite ore, you are leaching it with the help of caustic soda, that is NaOH, wherein water soluble sodium aluminate is formed. Sorry, it is not a precipitate, water soluble sodium aluminate. Now the iron oxide which is present in the impurities, that is the gangue, it does not dissolve in aqueous sodium hydroxide. It is then separated out by the process of filtration. But silica in the gangue, silica is present, SiO2, it dissolves in this caustic soda, that is sodium hydroxide, to form sodium silicate, soluble sodium silicate. Now aqueous sodium aluminate, it is diluted by putting in water and cooled to 50 degrees Celsius, and this results in the precipitation of aluminium hydroxide. So you can see here, sodium aluminate, when treated with water, it is diluted by putting in water, cooled to about 50 degrees Celsius, you get NaOH with the required thing, that is you get aluminium hydroxide. This is about the Byers process. Let us see what is done with this aluminium oxide ahead. Before that, we will see about the Hall's process. What is the basic technique behind the Hall's process? In the Hall's process, the ore is powdered and then leached by heating with aqueous sodium carbonate. Basic difference you got here. Byers process, the ore is powdered. Yes, here also the ore is powdered. There it is leached by sodium hydroxide, that is caustic soda, whereas here it is leached with the help of sodium carbonate. Please do not get confused. In the digester to form water soluble sodium aluminate. There also you get water soluble sodium aluminate. Then the insoluble impurities are filtered out. like your silica or titanium oxide. The filtrate is warmed and neutralized by passing carbon dioxide gas through it, which results in the precipitation of aluminium hydroxide. So you can see here bauxite ore, when leached with sodium carbonate, you get sodium aluminate with the liberation of carbon dioxide and water. Look at the equations very carefully. Then this sodium aluminate, you can see, when treated with water and carbon dioxide gas is allowed to pass through it, you get the precipitate of aluminium hydroxide, which is required. Now this precipitate, earlier also you have seen, let us go to the previous slide. You have got aluminium hydroxide in Bayer's process. Here also you get aluminium hydroxide in Hall's process. This precipitate of aluminium hydroxide, which is obtained in both Bayer's and Hall's processes, it is filtered. Then the precipitate is washed, dried, and that calcined by heating at a temperature of 1000 degrees Celsius to obtain alumina. Now you can see here aluminium hydroxide giving Al2O3 with the liberation of water. Now we have to obtain aluminium. So our next step is electrolytic reduction of alumina. Now you have got alumina. Our next step is to get aluminium from alumina, where you have to use the process of electrolytic reduction of alumina. Reduction, Al2O3, aluminium oxide, alumina. From that you have to obtain aluminium, so that oxygen has to be lost, it has to be removed, so the name is reduction. Now how this technique is carried out, let us see what happens in this method. Here electrolysis, you well know what is electrolysis of molten mixture of alumina whose melting point is greater than about 2000 degrees Celsius is done in a steel tank. You can see here a steel tank. This tank has a graphite lining on the inner side. Inner side of the tank, you can see this graphite lining. This lining does the work, it acts as the cathode. So look at the name, cathode, that is the graphite lining. A set of graphite rods which are dipped in the molten electrolyte, they act as anode. So this graphite rods which are introduced here, they are acting as the anode. So the graphite lining on the inner side of the cathode is, inner side of the tank is the cathode, whereas the graphite rods immersed in the electrolyte, they are the anode. Cryolite, that is Na3AlF6 and fluorspar CaF2 are added in this mixture to lower its melting point up to 1000 degrees Celsius. You know melting point has become greater than 2000, which has to be lowered down. So these two things have to be added. What happens over here? Aluminium is found to get deposited on the cathode on passage of electric current. It is electrolysis. So when you pass electric current through the electrolyte, you will find aluminium getting deposited on the cathode. Cathode means this graphite lining. Now molten aluminium, it is heavier than the electrolyte, like precipitate. So it is heavier than this electrolyte. So where it will get settled, it will be collected at the bottom of the tank, and from there the aluminium is taken out from time to time, whereas you will see that the oxygen gas is liberated at the anode, means on this graphite rods. Let us see the electrode reactions, anode reaction and cathode reaction. Now as I have told you, the liberated oxygen, it reacts with this graphite. In last year you have studied about graphite. What is graphite? Graphite is nothing but the ore of, not ore, you can say form of carbon. You have studied diamond, graphite and fullerene. So you know graphite means nothing but carbon. So this liberated oxygen in the reduction process, it reacts with this anode and forms carbon dioxide gas. Graphite is carbon combining with oxygen, so carbon dioxide gas is released, and hence the anodes have to be changed from time to time because they get oxidized during the electrolysis of alumina. Now you can ask me how they get oxidized, because they come in contact with the liberated oxygen. And so if you don't replace them, then further when you use the same anodes, then the oxygen gas which will be liberated, it will not get a chance to react with carbon, and then the entire procedure or the process somewhere it will go wrong. So here we have completed the entire process of extraction of aluminium. You have to learn it or remember it stepwise. In the first step, you are going to just know about its ore. Now, how questions can be asked over here? One textual question that we will discuss later on. First is, draw a neat label diagram of electrolytic reduction of alumina, or they can ask you about the Bayer's process or Hall's process, or they can give the paragraph you have, and different questions will be asked on the paragraph. As to if you take an example of electrolytic reduction, they can ask which substances are added to the mixture to lower its melting point. Then you will say that these two substances along with their chemical formula. What is deposited at the cathode, what is deposited at the anode. Then give the cathode reaction, give the anode reaction, why the anodes have to be replaced from time to time. Draw a neat label diagram showing electrolytic reduction of alumina. These are the different ways in which question can be asked. There are very rare chances that they will ask you the entire question of extraction, but each and every reaction you have to study in this extraction process. Now we move towards the last topic of this chapter. Today we will just see what is corrosion of metals along with different examples. In our next session, we will see how this corrosion can be prevented, which are the different methods to prevent it. Corrosion of metals. I need not have to explain you this term, because in chapter number 3, formation of rust, you have studied about corrosion. You have studied about its definition also. What is the general definition of corrosion? Due to the various components of the atmosphere, oxidation of different metals take place, resulting in the damage of the metals, which is called as corrosion. In chapter number 3, we had seen corrosion of iron. Now you know that rusting of iron articles, it causes large financial loss. Thus, the corrosion of iron, that is rusting, is a very big problem in India, where we have different grills or doors and all which are made up of iron. After all, if you see that corrosion is a harmful chemical reaction. Different examples we will see. First is iron. It reacts with moist air and a deposit of reddish substance, that is ferric oxide or rust, is formed on it. I will not explain this in more details, because this entire formation of rust along with the different chemical reactions you have studied in chapter number 3. So this is the first example. Second example is about the patination of copper. Carbon dioxide in the moist air, it reacts with the surface of copper vessel. You have seen after a particular amount of time, copper vessels, in the earlier days, copper vessels were used on a large scale. They used to turn greenish. So that was nothing but the combination of copper with carbon dioxide which is present in the air. So copper loses its shine or luster due to the formation of greenish layer. It is the layer of copper carbonate. It reacts with carbon dioxide, CuCO3 on its surface. This is called patination of copper. Now how to remove this layer, that we will see in the preventive measures. The next is, you know that silver articles, when exposed to air, they turn blackish after some time. Silver, that is Ag, it reacts with oxygen from the air or sulfur gases from the air and forms silver sulfide, that is Ag2S, which is the reaction of silver with hydrogen sulfide present in the air. One more example is By oxidation of aluminium, a thin layer of Al2O3, that is aluminium oxide, forms on it. So these are the different examples of corrosion of metals. Now, as I have told you, this corrosion is a dangerous or an undesirable chemical reaction. So, if the metals are allowed to corrode for a large amount of time or days without attending them, then it can lead to high financial loss. So somewhere you have to prevent this corrosion. There are various methods which are used to protect the metals from corrosion. So what are these different methods? Which are the different techniques that we are going to study in our next session? Along with that, because hardly it is a topic left of 5 to 10 minutes. After that, immediately I will start with the discussion of textual exercise, and hence I request all of you, when you attend the next session, be present with textbooks in your hands for marking the textual answers, because we are going to discuss it. Till then, we wind up with our today's session. Thank you, dear children.